Assalamualaikum and good afternoon, everyone. We are from Group D4, and today we are going to present about the journal paper that we have chosen. The title of the journal is Synthesis and Characterization of D-aqua-dinicotinamide cobalt-2 chloride. But first, I am going to introduce myself first. I am Nur Shaila Shamimi binti Muhammad Zamri, and my matric number is 203978.
Hi, my name is Afrina Mardiah binti Abdul Manan and my matric number is 204158.
Assalamualaikum warahmatullahi wabarakatuh. My name is Farah Amira binti Zulkifli and my matric number is 200423.
My name is Nur Farahana binti Zainal Abidin. My matric number 200871.
I'm Hagaliasri Madhyarasa, matric number 203062.
This is the content that we are going to include in our presentation today, and I will start first with the introduction. Cobalt nicotinamide had been synthesized more ratio in 1:2 of metal to the ligand in methanol. The complex was characterized by atomic absorption spectrophotometer, conductometer, UVB spectrophotometer, magnetic susceptibility balance, and FTIR spectrophotometer. Other than that, the result of atomic absorption spectrophotometer showed that cobalt in the complex was 14.40%. And the molar conductivity showed that the complex was 2 to 1 electrolyte. The moment magnetic showed that the complex was paramagnetic. The infrared spectra indicate that groups of primary NH and carbonyl were coordinated to the center ion of cobalt. And lastly, the molecular geometry of this complex is octahedral. Next, I'm going to proceed with the synthesis of complex, where a solution of 1.903 gram of 8 mole of cobalt chloride hexahydrate in 50 ml of ethanol was added dropwise to a solution of 1.954 gram of 16 mole of nicotinamide in 50 ml of methanol under continuous stirring at room temperature. After 60 minutes of extra stirring, it was allowed to stand for 44 hours. The precipitate form will be filtered with a Bushnell panel, and then it will be washed with methanol. After that, it will be left to dry off.
So now let's move on to the point group and type of ligand. So for the point group of this complex, the geometry of this complex is octahedral. It has C2 rotation axis at the middle of the water ligands which that is attached to the cobalt-2 plus ion. It also has the sigma H plane, which means the point group of this complex is C2H. For this complex, which is diaqua-dinicotinamide cobalt-2 chloride, it have two ligands which are nicotinamide and water. For nicotinamide, they are bidentate ligands as they have 2 points of attachment, while water they are monodentate ligands as they only have 1 point of attachment. Okay. For the strong or weak field ligands, nicotinamide and water are weak field ligands. Okay, for the valence bond theory, the first one is the orbitals of cobalt-2 plus ion. They occupy 3d orbitals with 7 electrons, and as we can see there, there are 3 unpaired electrons. And then for the hybridization, there are 6 ligands that donate electrons, and each ligands donate a pair of electrons, which means 6 pair of electrons donated, and the hybridization become sp3d2. The oscillation number of cobalt is +2. The electronic configuration of cobalt-2 plus is argon 3d7, and the hybridization becomes sp3d2. This complex is a high-spin complex, and the magnetic nature is paramagnetic, and it occupies outer orbital complex, which the geometry is become octahedral. For the crystal field theory, the electrostatic interactions between the electrons of the ligands and the loops of the d orbitals is the reason why they split. The energy levels of Eg are higher, which is 0.6 delta knot, while T2G is lower, which is 0.4 delta knot. Since there are unpaired electrons in this complex, so the complex is paramagnetic. For the ligand fate theory, cobalt 2 plus ion is high spin. It has a smaller splitting between the lower and the higher d orbital levels. Electron can more easily go to the higher level rather than pair up until the lower level. And that are the molecular orbital diagram for Ml6 octahedral. So we proceed to the next presenter. Thank you.
Thank you, Afrina. Assalamualaikum and good evening, everyone. Now I will proceed with the next part, which is the compound characterization. This includes the IR spectra, magnetic properties and stereochemistry of the compound. Now I will be presenting the IR spectra. Here we have two spectra. One belongs to nicotinamide, which is the free ligand itself, and another one is the spectra for the coordinated complex. Both look alike, but they are slightly different in the absorption of the wave number for both of the spectra. The next, I already observed the obvious spectra that can be compared and determine the functional group. We start from the highest wave number to the lowest wave number, which is from the left side to the right side. So here for nicotinamide, there is a shift from lower band to higher band, which is from 3369 centimeter negative 1 to 3404 centimeter negative 1. For the second peak here, there is a shift to higher band. And for the third peak here, there is a shift to lower band, which is from 1681 to 1668. And the last peak that were observed here is undergo shift to higher band. So this is the tabulated data for the previous slide. For the highest wave number, which is the left side of the spectra, it belongs to amine NH stretch, since the compound of nicotinamide have NH2 group there. Then from 1640 to 1550 centimeter negative 1 is the NH band. For amide C double bond O stretch, the wave number is from 1690 to 1630 centimeter negative 1. And the last one is the carbon nitrogen ring stretch, which is the wave number is from 1600 to 1500 centimeter negative 1. The shift to higher band for amine NH stretch is caused by the shortening of the NH bond on the NH2 group. Now, the NH2 group coordinated with the central metal atom, which is cobalt in the coordinated complex. Hence, the vibrational energy become higher in the complex compared to the free ligand itself. It is also seen that the band of C double bond O nicotinamide undergoes a shift to lower band, which is from 1681 centimeter negative 1 to 1668 centimeter negative 1. This indicates that the oxygen of nicotinamide coordinated with cobalt 2 ion. Therefore, there are two different atoms from one ligand bonded to central metal atom, making it a bidentate ligand. The donor atom are primary nitrogen and O carbonate. That's all for the IR spectra. Now I will pass this presentation to Farhana for the magnetic properties and stereochemistry of this compound complex.
Now, I will continue with magnetic properties for diaqua dinicotinamide cobalt chloride. So basically, this complex has paramagnetic properties. The magnetic moment for this complex is 5.30 Bohr magnetron. Actually, how can we know the magnetic properties? We can determine based on the number of anti-electrons. And here the oxidation state of cobalt ion to cobalt ion is +2, and the DN configuration is D7. Based on the formula above, the coordination number for this complex is 6, thus it will have an octahedral structure. Since weak field ligands present in the complex, it will be high spin complex with a possible configuration T2G5 Pg2 with 3 anti-electrons. The presence of these 3 anti-electrons make the complex become paramagnetic. Next. Here I just want to show the metal complex in 2 dimensions. And as we can see here, the metal ion is attached to 4 ligands, which are 2 water and 2 nicotinamide. Since the nicotinamide is bidentate ligand, thus the coordination number is 6. There is also chloride as an ion for this complex. Next. Here I want to show the metal complex in 3 dimensions. As you guys can see here, the pink color is cobalt 2 plus ion, the red color is oxygen, the blue color is nitrogen, the gray color is carbon, the white color is hydrogen, and the green color is chlorine atom. Now I will pass to Hagalia to continue this presentation.
Now I'm going to explain about application and conclusion of diaqua dinicotinamide cobalt chloride. One of the applications of this complex is it forms a type of cobalt substituted hemoglobin and have a function of oxygen uptake such as hemoglobin itself. Hemoglobin is a cell that located in blood carries oxygen throughout the body. Secondly, it forms a coenzyme associated with vitamin B12. Coenzyme is a substance that enhances the action of enzyme and helps to speed up the chemical reaction, whereas vitamin B12 is a type of water-soluble vitamin that involves in metabolism and it's a cofactor for DNA synthesis. Thirdly, it has a pyridine derivative with an amide group in gamma position poses a structural analog with first-line anti-tuberculosis drug isonic acid. Tuberculosis is a potentially serious infectious disease that affects lungs. Fourthly, it helps in the formation of major drugs for tuberculosis chemotherapy. As a conclusion, diaqua dinicotinamide cobalt chloride can be synthesized by stirring a solution of cobalt chloride hexahydrate and nicotinamide in methanol at room temperature for 1 hour. It adapts an octahedral structure with primary nitrogen and oxygen carbonyls which are coordinated to cobalt-2. It is very beneficial in the medical field, especially to cure contagious disease such as tuberculosis, human immunodeficiency virus, which leads to vectors. And this diaqua dinicotinamide cobalt chloride is a paramagnetic. That's all from us. Thank you.